Okay, boys and girls, Mrs. Reed to the rescue. So I'm going to walk you through on how to complete Lesson 27 problem set pages. So we're going to start with number 1, and it says use the pictures to model equivalent fractions, fill in the blanks, and answer the questions. So equivalent, if you listen to it, it sounds an awful lot like equal. So equivalent fractions means fractions that are equal or represent the same amount. So if we look at number 1, we have 2 fraction strips there. The first one has 1, 2, 3, 4, 5, 6 parts. So each one would be 1/6, and I'm going to label each one with 1/6. The second fraction strip has 3 equal parts. So that means those are thirds. So I'm going to label those each with 1/3. And I know you guys know how to do that. Now it says 4/6 is equal to how many thirds? Well, I'm going to shade in 4/6, 1/6, 2/6, 3/6, 4/6. And I'm going to say, okay, how many thirds will I have to shade in the same amount? Well, I shade in 1/3, I get to that place. If I shade in 2/3, look at that. I've shaded in the same amount in both fraction strips. So 4/6 is actually equal to 2/3, 1/3, 2/3. And I can write it in unit form like this with words, or I can write it in fraction form. 4/6 equals 2/3. Okay, now they want you to look at your pictures. And when you come down here, they want you to tell what happened to the size of the equal parts when there were fewer equal parts. So in this one, there were 6 equal parts. Then they changed it to 3 equal parts. So there were fewer equal parts. What happened to the size of the units? Well, here they were smaller, but when there were less parts, the parts got bigger. So we will write the parts got bigger. Then it says, what happened to the number of equal parts when the equal parts became larger? So once the parts get bigger, the number of equal parts, so the number of parts gets smaller. Okay, let's try that again with the second example. So I'm looking at my fraction strips, and the first one has 2 equal parts. So I'm going to label each one with 1/2. The second one has 1, 2, 3, 4, 5, 6, 7, 8 equal parts. So I will label each part with 1/8. Remember how important that is to do. Now it says 1/2 is equal to how many eighths? So first I'm going to shade in 1/2. And then you say, okay, how many eighths is that equal to? Well, I'm going to start shading. 1/8, 2/8, 3/8, 4/8. Aha. Right there, if I shade in that many eighths, I have the same amount of my fraction strip shaded as I do when I shade in 1/2. So 1/2 is equal to 4/8. Again, written in unit form with words. Okay? Or I can write it in numeric form, 1/2 equals 4/8. And again, you find that out by counting 1/8, 2/8, 3/8, 4/8. Okay? Remember, the whole stays the same, and please notice that both my fraction strips are the exact same size. Okay, that's a really important concept too. So the question says, what happened to the size of the equal parts when there were more equal parts? Well, let's look at it. First we had 2 equal parts, but when we had more equal parts, 8 parts, the size of the parts got smaller. So the size got smaller. And then it says, what happened to the number of equal parts when the equal parts became smaller? So now they want to know, what about the equal parts? The parts get smaller. What happens to the number of parts? So the number of parts gets bigger. And I know that's a little confusing because first you're talking about the number of parts, you're talking about the size of the parts. So you really have to think about what the question's asking you and make sure you're referring to the pictures. Okay, let's go to the word problem. So this word problem, I really like this because it makes you really stop and think. It says 6 friends want to share 3 chocolate bars that are all the same size. Really important. I'm going to underline my knowns. 6 friends want to share 3 chocolate bars. They're all the same size, okay? Which are represented by the 3 rectangles below. When the bars are unwrapped, the friends notice that the first chocolate bar is cut into 2 equal parts. The second is cut into 4 equal parts, and the third is cut into 6 equal parts. How can the 6 friends share the chocolate bars equally without breaking any of the squares? Well, so first I'm going to go to the first fraction strip, and it says it's cut into 2 equal parts. I'm going to do my best to cut it in half, okay? Then it says the second is cut into 4 equal parts. So I remember how I do that. First, I'm going to make my halves, and then I'll cut my halves in half, and now I've got 4 equal parts. And then the last one says it is cut into 6 equal parts. So for 6 equal parts, I'm going to make thirds, and then I'm going to cut my thirds in half. Okay, so I've got these 3 candy bars, and they're all cut differently. How can I make sure that each person gets the same amount? Well, if I look at this, I can say, well, what if one person got this much and another person got that much? That's 2 people. They each have a half a candy bar. The third person, what if we gave them half of this candy bar? They would all still have a half, even though that's composed of 2 smaller pieces. And then the fourth person would get this. Again, they get a half, even though it's made up of 2 pieces. The fifth person, we could give them 3 of these. That would give them a half a candy bar. And the last person, we would give them these 3 pieces, and they would also get a half a candy bar. So how can the 6 friends share chocolate bars equally without breaking any of the pieces? They can share them like I showed with my circles. People get a different number of parts but they all still get 1/2. There. And that's page 1 of problem set 27. I hope that helped. Thanks, boys and girls.